In this video, we're going to look at a few more examples of using VSEPR theory in order to predict molecular structure. So in this example, I've got three different molecules that are formed between reactions of phosphorus and chlorine. All right, so we got PCl5, we got PCl4 plus, and PCl6 minus. So starting with PCl5, again, first thing we want to do is start with a valid Lewis structure. So we want to ask ourselves, how many valence electrons do we need? So how many valence? Right, in this case, phosphorus has a characteristic valence of 5. Plus chlorine has 7, a characteristic valence of 7, and there's 5 of them. So that accounts for the 5 chlorines. And so that's going to give us a total of 40 valence electrons. All right, so going through connecting all of the atoms. So we're going to have all 5 chlorines attached to the phosphorus. Right, so I've attached all 5 chlorines to the phosphorus. Now, in order to finish this Lewis structure, going to fill in the octets for the chlorines, giving them the remaining lone pair electrons. Okay, and so that gives us a valid Lewis structure as a starting point, right? So we've accounted for all 40 valence electrons in PCl5, and we've connected them to the central atom. Again, since phosphorus is in period 3 or below, it's fine with this expanded octet that we see here. So that's fine. And okay, so we have this Lewis structure that we can start with. So now we just have to consider the three-dimensional geometry. So in order to do that, we calculate the steric number. So calculate the steric number for the central atom. Central atom in this case is the phosphorus in the center. And if we calculate the steric number, that is going to give us, we're going to have 5 bonded atoms plus no lone pairs around this central phosphorus. And so that's going to give us a total steric number of 5. So we have a steric number of 5 with no lone pairs, right? So that's going to give us a trigonal bipyramidal geometry. So from VSEPR theory, we would get a trigonal bipyramidal geometry. So again, you can find tables for this online. I've shown the table for VSEPR theory geometries in the previous 2 videos. So if you have a steric number of 5 with no lone pairs, that gives you a trigonal bipyramidal geometry. Okay, so for PCl4 plus, again, starting with how many valence electrons we need here, right? So how many valence electrons do we need? Again, phosphorus has a characteristic valence of 5, starting with that. And chlorine has a characteristic valence of 7. This time there's 4 of them. That accounts for the 4 chlorines. And again, since we have this positive charge here, overall, that means we're going to have 1 less electron than we have protons. So we're going to have to subtract 1 electron from these characteristic valences. And that's going to give us a total of 32 valence electrons. So now if we connect all of the atoms to get our Lewis structure, we'll have a chlorine there, chlorine there, chlorine there, and chlorine there, right? And so from here, just fill in the octets for the chlorine atoms across the board. And so that leaves you with the 32 valence electrons for PCl4 plus. So our Lewis structure would be here, right? Adding that plus charge. Okay, so now let's calculate the steric number again. So calculate steric number. And so if we're calculating the steric number here, again, we have no lone pairs. We got 4 attachments plus no lone pairs here. So that's going to be a steric number of 4 with no lone pairs. So that's going to give us a tetrahedral geometry. So tetrahedral geometry for PCl4 plus. Okay, So now the last one that we have here, PCl6, establishing how many valence electrons we need. Again, characteristic valence of 5 for the phosphorus, plus 7 for the chlorine, and there's 6 of them. All right, so that accounts for our 6 chlorines. And we have an overall negative charge. That means we have one more electron than we would for the characteristic valences. So we're going to have plus 1 there. And so that's going to give us a total of 48 valence electrons for PCl6 minus. So again, forming the Lewis structure here, connecting all 6 chlorines. Again, phosphorus is going to be fine with this because it can accommodate an expanded octet. All right, 1, 2, 3, 4, 5, 6. Got all 6 of our chlorines surrounding the phosphorus. And from there, just add in lone pairs, right? Adding in lone pairs for the chlorines all across the board. And so when you sum up all of the valence electrons here, you get all 48. So once we add this charge, we have a valid Lewis structure. So again, let's calculate the steric number. So calculate the steric number. Steric number, we got 6 bonded atoms plus no lone pairs around that central phosphorus. So that's going to give us a steric number of 6 in total with no lone pairs. So overall, that's going to give us an octahedral geometry, right? So VSEPR theory will predict an octahedral geometry. Okay, excellent. Okay, so we get an octahedral geometry for PCl6 minus, tetrahedral for PCl4 plus, and a trigonal bipyramidal geometry for PCl5. So even though these are all compounds made from phosphorus and chlorine, obviously they're going to have different geometries based on the amount of chlorines that are around that central atom. And we showed this using VSEPR theory. So here you can see that, even similar looking molecules and ions, we can, be able to discern their differences in three-dimensional structure using VSEPR theory.